Hi, Cam 1120C. I just realized a student brought this question to me, and I realized it's much harder than any of the examples that the book gives you. This is from problem set 4A. And so I thought I would show you guys how to do it, because it's really hard. Okay, so we're taking some ice and we're adding it to some water. And heat travels from the water to the ice. That amount of heat melts the ice. But then we also have heat traveling from the water to the melt, and that warms it up. Okay, so we have Q of melting, and then we have Q of warming. Okay, so first let's figure out Q of melting, because that's easy. To figure out Q of melting, you use Q equals N delta H, right? N is going to be 115 grams divided by the molar mass. 1 mole of water is 18.02 grams. And then we're going to multiply that by the molar enthalpy of melting, which is 6.04 kilojoules per mole. And when I punch that into my calculator, I get 38.5 kilojoules. So that's how much heat the ice absorbs when it melts. Okay? So that's going to cool down the warm water. Right? And so that cools the warm water. And we can say that the water loses this much heat. So Q of the water is negative 38.5 kilojoules. In other words, that Q melt equals negative Q cool, which is MCS delta T. So now we're going to expand this equation. That's MCS TF minus TI, right? Because delta T is TF minus TI. All right, and then what I want to do is divide both sides by MCS. So I get negative Q melt over MCS equals TF minus TI. And so if I add TI to both sides, then I get negative Q melt over MCS equals, plus TI equals TF. This TF represents how much the water is cooled by melting the ice. So we're going to plug in our numbers. And we have negative 38,500 joules over, let's see, I believe we had 2.72 liters. So that's 2,720 grams. And CS is 4.184 joules over grams times degrees C. And our initial temperature was 89 degrees C. And so when I plug this all into my calculator, negative 38,500 divided by 2,720 times 4.184, I get negative 3.38 degrees Celsius plus 89.0 degrees Celsius. So just to melt the ice, that cools the water down, that cools the warm water down by 3.38 degrees, and our new temperature is 85.6 degrees Celsius. So now we have 2,720 grams of water at 85.6 degrees Celsius mixed with 115 grams of water at 0 degrees Celsius. And this is the hard part. Heat's going to flow from the hot water to the cold water until their temperatures equilibrate. So, Q that flows out of the hot water, we'll call that negative Q hot, equals Q that flows into the cold water. Okay, so we have M CS TF minus 85.6, oh, and this is M hot, times CS times TF minus 85.6 equals M cold times CS times TF minus 0. Okay, so we're going to divide both sides by CS to just make our lives a little bit easier. And now we're going to plug in our numbers. So I got 2720 times TF minus 85.6 equals 115 TF. Right, because the mass of the hot is 2,720 grams, and the mass of the melted ice is 115 grams. Now it's just a matter of doing some algebra and solving for TF. That'll be the final temperature of our mixture. So if I distribute through on the left-hand side, I get 2720 TF, I'm sorry, it should be negative 2720 TF, plus whatever the product of 2720 and 85.6 is. They're both negative, so it becomes positive. 232,832. That equals 115 TF. And again, that's negative 2720. Okay, so now let's add 2,720 TF to both sides. We end up with 232,832 equals 115 plus 2720, 2,835 times TF. And then to solve for TF, we divide both sides by 2,835. So 232,832 over 2,835 equals TF. All right, and let's punch this into our calculators. 232,832 over 2,835. And we get 82.1 degrees Celsius. Whew, that's a tough problem.